Okay, so good morning, everybody. Oh, well, actually, good afternoon, everybody. It's 1 o'clock. And I hope you're all doing wonderfully good this day, nice, cool day. And let me welcome you to our fourth lesson in robotics and coding, brought to you by the Department of Basic Education and sponsored and together with Africa Teen Geeks, Africa Teen Geeks. And my name is Mr. A.F. Gabriel, and I am your teacher facilitator for the session today. Okay, now, I know we got to some really exciting stuff with our coding yesterday, because in only our third lesson, we managed to get to this point where we were making a sprite, or, the robot that we were talking about in inverted commas, we were making it move with some coding instructions. And if you will remember, um, yesterday Trevor asked a question about animation, and somebody else, and I forget the name of the person, asked a question about repetition. And both of those concepts are going to make part of our fourth lesson for today. So exciting stuff, and let's get straight into it. Now, before we jump onto MS Zora and do some coding, because repetition is a programming concept that needs some elaboration and some explanation, yes, we can quickly write some code and you can see what's going on, but then you might not fully understand the concept as well. So I want to do both. I want to share with you mostly today a small, brief presentation, which I'm going to do through some slides about repetition in coding. But first, I just want to quickly recap everything that we have done up until this point. So let's have a look at our next slide. The story so far. In lesson 1, we learned what is robotics and coding. And I also taught you what is an algorithm, right? Don't forget that word, a sequence of steps that we follow in order to achieve an objective in coding. In lesson 2, we introduced you to block-based programming, and we were using the MS Zora platform, MS Zora blocks. I also taught you how to create an account, to sign up for one, and of course, thereafter you log in with your username and your password, and then you can use your own account. Okay, then lesson 3, which was yesterday, we wrote our first set of code, and we actually, for the first lesson, you guys did pretty well, and we did quite a lot in that first coding lesson. And of course, in that lesson, we made a sprite move on the screen. Okay, then lesson 4, which is today, is going to be called sprite costumes.
I didn't. Oh, sorry. Hello.
Hello, yes, somebody was speaking. Okay, I think that's right. Huh? Okay. Okay, sorry about that. We had a few technical glitches there. Okay, now let me proceed with lesson 4. Lesson 4 is sprite costumes and how to manage this thing called repetition, right? Okay, now yesterday and the day before, no, yesterday, you would have been introduced to the idea of what a costume is. We'll go back there, and when we go back into the blocks, we'll show you again what the sprite costume is all about. But today, really, what I want to talk about is this concept called repetition. Another word for repetition is this word, loop, right? So you know what a loop is. Sorry, got muted there. Okay, just to repeat, what we're going to do today is we are going to work with these things called repetition, also known as a loop. Now, you might have a visual picture of what a loop is. So let's have a look. Here we go. You see that? Now you must have seen that before. That's a figure of 8 loops. Loop, very common in those old race cars, the remote control race cars. It used to be, the track used to be in this figure of 8 shape with a little bridge on the 8 shape section. So yeah, the idea behind a loop, though, let's look at the concept. Now watch my mouse pointer. You can see that, oh, sorry, you can see that the loop actually repeats. It starts at a particular point, and then it goes around in the figure of 8, and eventually it'll come back exactly to where it started. And that's the whole idea of a loop. You can run kilometers and kilometers on this track, but it only takes up a finite set of space. For example, your car can drive around and around this loop, but it's really in a small space. By the end of your playing, you might have driven for a good couple kilometers, but you never quite actually traveled so many kilometers. You are simply going around and around in this figure of 8 loop. So that's pretty cool about loops. We can repeat things without having to go too far. Okay, now what else do loops do? They allow us to reuse. Now, obviously, that's with race cars. We are talking about coding. So what do loops do? They allow us to reuse blocks of code that we already have without having to retype the blocks. Now that's pretty cool. Okay, this is going to be a lot of advantages. So what are some advantages do we think loops can have? Now let me pose that question to all of you listening to me out there. Having seen this idea that we can use a loop to repeat blocks of code, what advantages do you think this could have for us as programmers? Just raise your hand on your Zoom platform, and I will give you an opportunity to answer if you'd like. Oops. Okay. I accidentally pressed my keyboard there, so you had a sneak preview of one of the advantages. Let's look at that. Our code is shorter. Obviously, if we can repeat code, if we can repeat blocks without having to retype them, then our code is going to be much shorter than it would have been if we were retyping the same code. Second, obviously, if the code is shorter, this is going to improve the readability. Remember, we are programmers, we're writing code. The longer the code is, the more difficult it is to understand, to read, and remember also when it's not working and we have to fix it. And that's called debugging. Whenever we are fixing a program, we call it debugging the program. Whenever we're doing this debugging process, longer programs are going to be a lot more difficult. We're going to have to scroll up and down through all the code to look for things. So improving readability goes a long way in helping us fix our errors. And of course, saves time. In all areas, saves programming time, fixing time. Okay, now we're going to use some repetition today, as suggested yesterday. And you will see first, before we look at repetition, they're not, this is not just one type of repetition structure that we could choose when we program. Even in Zora blocks, there is more than one type of loop. So we call this a loop, but there are different types of loops. Now, with different programming, there generally there's 2 categories of loops, but there's a third one that comes in with the MS Zora blocks that we are using. So I'm going to introduce you to that one also. Here we go. The first loop type and the most commonly easy one is the counting loop. And the counting loop is suggestive, exactly why it's called the counting loop, is it counts, which means when you are using this loop, we need to know in advance how many times that we want to run the loop? How many times will the loop work? Now, a good way of thinking of a counting loop is to think of laps in a race. And when I say race, I mean those car races, like the Formula One races. If you think about the Formula One driver, um, the driver knows how many laps are needed. By the way, does anybody know how many laps are they in a Formula One? You can reply on the chat if you like, instead of me having to mute anybody. Let's just see any smart person in this room. No, 200. Formula One race. I think the driver will pass out by the end of 200. 3 is too short. Nope. Nobody's getting it right. Okay, let's move on. Let me give you the answer quickly. Formula One races officially have 52 laps. We got to go 52 times around the track, and then that brings you to the end. Now, so the driver knows before the race starts. He knows that he's got to go around the track 52 times, and interestingly enough, he will always know how far he's going. How does he know that? Anybody? Yes, reply through the chat. How does the driver know how far he's gone in his race? Aiden says he counts in his head. Jordan says the speedometer. The speedometer tells you how fast you are going. Sean is correct. A lap counter. People, inside the car is a lap counter. And every time he passes that section where it says the finish line, it's also the start and the finish is the same spot. Once he goes past that, when he comes around to that spot again, just like on that figure of 8, the lap counter in his car is tracking the number of kilometers that he's traveled around the track, and then it ticks off 1. So he has this thing in his car, and he always knows how many laps he's done. He can look at. He doesn't have time to count it in his head. Formula One drivers are a hell of a concentrating on the changing of gears and speed and all sorts of things. So they certainly will lose track of it if they have to count in their heads. The car has a counter in it. Also, notice when they come to the last lap, who knows what happens when there's a last lap? What happens? What does he see at the finish line? Just before he's coming to his last lap, you'll find that there is a technician that will wave a black flag. When you see the black flag, then you know that's your last lap. And when you come around the next time, the race is over. And Ronell is correct. When the race is over, they wave a checkered flag to show you that the race is over. But I'm saying all this because the most important thing to note here is that firstly, for a counting loop, we always need to know how many times we're doing it. The driver knows 52 times. The loop always knows how far it's gone. The driver can always look at his lap counter in the car to see how many times he's gone around the track. And he can subtract, obviously, from 52 to work out how many he's got left. You see? So the counting loops in our programming language of MS-Zora and our block programming works exactly the same way. So I want you to always think of this race car idea, and you will know exactly, how, well, you'll have an idea of how that loop is going to work, right? Okay, now, the second type of loop, right? The second type of loop is called a conditional loop. A conditional loop. Now that word condition means, let's use a sentence. On condition that, let me be more specific. Your mother might say to you, hey, on condition that you wash the dishes, I give you $10. So how do you get the $10? Yes, you've got to wash the dishes. So when your mother comes into the kitchen and the dishes are unwashed, you get nothing. But if the sink is clean, you get 10 Rand. That is a condition, which means the dishes could be washed in 5 minutes. Maybe you want that money quickly. In 5 minutes, you'll do it. But maybe you're a lazy person and you'll go and sleep and lie down, and 1 hour later, you'll go and wash the dishes. In the end, the condition is met. The dishes are washed, but there's no telling how long it could take. It could take 5 minutes, it could take 1 hour, it could take 2 hours. So this loop doesn't run for a specific period of time. It doesn't go exactly 52 like the laps in a race car, or 10 or things like that. It is controlled by a condition. So the loop will stop when the condition has been met. And that's interesting. We have a lot of control over programming when we use conditional loops. The last type of loop is not traditional in major programming languages, but it is included in MS Zora blocks, and so I want to introduce you to that one as well. We don't often use it, but it's very good for animations and graphics and things like that. And that is called a forever loop. Now, what does a forever loop do? A forever loop, exactly as it suggests, it actually runs forever. Which means it doesn't ever stop. It doesn't count and keep going up to a certain point. There is no condition to tell it to stop. It's just going to run all the way through. The only way to stop it is by pressing a stop button or something in our code. How will this be useful? Well, most of the time with games and animation, maybe there's something supposed to be moving around on the screen, and it's always got to be moving, like maybe a ball that's just bouncing around on the screen. In fact, a good example is a screensaver. You've all seen a screensaver. A screensaver is actually a program. So when a screensaver is running on a computer, it's running some code. And there might be a screensaver that's just drawing those pipes or whatever it is on the screen, but the pipes carry on drawing, it doesn't stop. And only when the screensaver program the whole program terminates, then the screensaver goes away. But while the screensaver program is running, it knows that it must continuously and continuously draw these pipes on the screen. Pipes is one of those Windows preset screensavers. So can you see? That's a forever loop there. The screensaver is programmed to continuously just running and running and running and running all the way through until the program itself is stopped. So that's a good example of where forever loop comes. Now, yesterday we wrote this program code. If you're all looking at your screen right now, we managed to complete this program to get the sprite to move. And if you look at this code, you will see that other than the costume and the go-to, which is the two starting things, everything else is repetition. Move 10 steps, wait 1 second. Move 10 steps, wait 1 second. Move 10 steps, wait 1 second. It's just over and over and over again. We are repeating the same blocks of code, which means that this program is long. And you can see I couldn't even fit it on the slide. There's more steps after at the bottom. And it's pretty long. And of course, we had to drag a lot of blocks in. And you saw yesterday when I wanted to change the 1 second, I think we had it on 2 seconds, and then I decided to change it to 1 second. I had to change it in all the blocks. So you can see the advantages of having a loop. Remember the three things I said? It's going to make your program more readable, so it's not so long. It's going to be very easy to fix errors. And look how much time it's going to save me. Instead of keep changing 1 second everywhere, I can change it in one place. The idea of repetition here is that we're going to use the wait block and the move block just once, and then thereafter we're going to repeat those two things. Okay, so coding time. Let us use a loop in MS Zora. Enough with the slides, right? Woohoo! Let's go for it. Let me close the slide presentation and just check if anybody might want to ask me any questions before I go into Zora. Let's log in here first. Okay, so while I am logging into the MS Zora website, is there anybody who want to ask me anything about what we've been talking about so far? Trevor, you got your hand up. All right.
Sir,
Yes.
are we still going to do the walking animation? I know it's gonna take a while.
Yeah, I know you're excited about that, Trevor. Yes, we are going to do it. We might be able to get to it towards the end of today. Let's see, maybe we will, right? If we don't do it today, we'll definitely start with it tomorrow. Okay, right. Trevor's very excited about animation, but so am I. I'm sure so are all of us. Let's go into the blocks and let's have a look at our code. Okay. Now, oh yes, I was just looking at questions. How many types of loops are there was a question. There are two types of loops, basically, conditional loops and unconditional loops, right? Will we be doing the loops? Yes, we're going to do a loop right now. Okay, and while my page is opening, any other questions? Okay, Lebohang, you've got your hand on. Okay, Lebohang, you can speak.
Okay, so sir, I wanted to ask if are we going to learn about more loops or are these just the ones that we're going to learn about now?
Yes, these are the ones that you're going to learn about now. They are all the loops that are in MS Zora blocks. So you will learn all of them that is in this programming language. Once you move from this language to things like Python, you will learn a little more of an advanced way of using loops. Right? Remember, MS, you guys are still in primary school, so MS Zora blocks is a very simple program, and programming can be quite challenging if you start in a very complex programming language. So what we're doing with you is we're using something simple and that you can find easy to use. And then when you get to high school and you switch to Python, for example, you will actually find it very simple. You'll find it a breeze to work with Python because of the experience that you've had with MS Blocks. But MS Blocks does keep it simple and it's not as complex. So the complexity will come a lot later. Remember, we must walk before we can run. Okay, now let's now load a. Okay, first let me just introduce you to the loops. Now the loops are under control structures, right? So remember now that just like the wait 1 second, which is the only control that we used from yesterday, all the loops are in the control structures. Now what I'm going to do is just to show them to you, I'm going to drag, oh, what is going on here? I'm going to drag them into my program window so you can see the three loops that I spoke about. Right. Now I had three loops that I introduced to you in the slideshow. Okay. There's a little bit of English that we must understand in terms of grammar, and that word is repeat until, right? For example, repeat these instructions until such time that something happens. Can you see that? That's just, communication in English. We understand what the word repeat means, do over. We understand what the word until means, it's indicating a condition. You carry on doing this until this condition is met. So what am I saying here? This repeat loop here, if you can see my mouse pointer on it, is saying repeat 10, right? And this is how the loop works. You'll find that it has the word repeat. It's got a number. Then it's got a space here where blocks can go. Now, although it looks like just one block can fit there, this looping control structure can get bigger and bigger and bigger as you stuff more blocks into it. So you can repeat as many blocks as you want to. But I want you to see as I pass the mouse around this repeat structure, how it works. Repeat, and then it comes here, and then you see this little arrow going back up to the top. This is telling us that now this loop must go back up, and then you go again and go back up. If you look at all the blocks, none of the blocks have any of those arrows saying go back up. So it's a single block that does a single thing. But this repeat block actually allows you to go back up. Now, this is a counting repeat block. It's saying repeat, and there's a number there. Can you see that number? The number is 10. Okay. When you go 10 times, then the loop is over. So this loop will run 10 times. All right, who counts? Not you, the computer counts. The computer has an internal counter and it keeps track of this loop as it's going. This number 10 can be changed. Here we go. If you want to make the loop run 5 times, then you can make it run 5 times. Okay, so that's all good. So you can now have what was that loop called? A counting loop. That was our first loop example. So, but to use the counting loop, you must know how many times you are going to count. 5 times or 10 times or 20 times or 52 times. So when you want to use a counting loop, you use this repeat loop. Okay, let's look at the next one. Okay, this is a conditional loop. It's not counting. Can you see there's no number? The entire structure looks exactly the same as the first repeat loop, but there's no number here. There is a little diamond, well, what's that? Hexagon. There's a hexagon shaped piece in there, because what you have to do to use this loop is you have to place a condition into it. Right, so and remember, with the blocks, you have to place a block that fits in there. I'm going to scroll down the screen just to show you. Can you see these hexagon shaped things? This block can fit in there, and you can use that block as part of the repeat. Okay, so these blocks are conditions. Can you see, is it touching the mouse pointer? That's a condition. With the computer, the condition has to be yes or no, right? Yes or no. Look at this one. Repeat is the mouse down. So this loop will carry on and on and on and on running until you press and hold the mouse down. You see, that's the condition. And these things are pretty cool because you can control. Now I went into the little sensing section where you can see what the the person using your program, what he's doing with the keyboard and things like that. Look at this one here. Where's that one? Ah, there we go. Key. You can now it will repeat until you press the space on the keyboard. And if you click here, you will find that you can change it to anything. Okay. Now, can you see how we can control sprites on the screen? We can find out, look here, we can find out if you press the up arrow, and then we can make something move up if we wanted to, right? Of course, we're jumping, we're going a little bit far there. I'm just illustrating how the loop works, but we'll see how much we can do in this time and whether we can get that far. And of course, the third loop that I want to introduce you to is the forever loop. And well, you can see the word forever there. There is nothing there. There is no number. There is no condition, because this loop does not stop. It's going to say go forever, and watch how this mouse pointer is going to roll. It's just going to run and run and run and run. So not a loop that we use all the time, but it's pretty good for animation and games. Okay, now let's use one of these loops, right? We'll start with the counting loop, because it doesn't need, I have to teach you the repeat loop. I'll have to teach you also how to use the hexagon shape thing, which will be another lesson, okay? I know some of you are smart and you can learn fast, but remember also, I have to cater for everybody, especially those who have never programmed before. Right, now, let's take this opportunity to show you how to open up a program that we've already saved. Now, if you remember yesterday, and who can remember, and you can reply on the chat group, please. Who remembers what we called our program yesterday? We made the guy walk a little bit. Our sprite, we made him walk a little bit, and then that's all the time we had for, and then we saved him quickly. And I taught you also how to save. Okay, Corbin and Ronell and everyone remembers it. Robot walk. And some of you have got the wording right with the capital R and the capital W. Well done, you guys. Okay, now I'm going to show you how we open that program. Yesterday, we click on File. Yesterday, we went to save to our computer to save it. Now you click from Load from your computer. Because I'm online, and whenever I download anything, it goes to my downloads folder. You will find a list of things on my downloads folder that we use. Now, if you look at the screen, you will see Robot Walk. I was actually fiddling with a couple of programs, so you'll see a few things there. So don't worry about those other ones. We're going to open Robot Walk, and we're going to click Open. And it wants to replace it'll ask you this question all the time. Replace the content. There's nothing even there. It's always going to ask you this content question. So make sure that you've saved your old program before you do this. If you click OK and you have a program on your screen here that you haven't saved, you will lose it. So just be careful there. And here is Robot Walk. And let's run Robot Walk quickly again so that we can see what it is doing. And run, and he's taking steps 1 second at a time. And then he stops and says hello to us, right? Okay, so how many times is he moving? Let's count from our blocks. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that was 8. 1, 2, 3, 4, 5, 6. Yeah, 8 steps, right? He's taken 8 steps. Am I right, guys? So he's moving 8 times. Okay, so what we are going to do now is watch first. Let me just separate the blocks. I need to take that out. That's our beginning section. We still want that costume to switch. We still want him to start from that position. And all of this stuff here. Oh, stop it, you guy. He's moving because I clicked on the blocks. Right, so here is our thing that's making him move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blocks over and over again. That's being repeated. And it's the same. Move 10 steps, wait 1 second. So what we are going to do now is we're going to chuck all this out. Look at the amount of code that is being chucked out that we don't actually need, because we are simply going to need to repeat these 2 steps. So we will go to our control structures and we will select a repeat loop structure. Okay, now you'll see that we're saying repeat 10 times. Our guy was repeating. He was walking 8. We gave him 8 separate movements, so we will change the 10 to 8. And we want him to repeat this. We want him to move 10 steps and wait 1 second. And we want him to do that 8 times because we had that 8 times there. So we take this code and watch what we do. We put it into the loop like that. You wait for the loop section to get a little grayed up and it'll join into the loop. You got to wait for it to get grayed and it's in, right? We can take it out. Remember also, it can get attached there. That means this is not part of the loop. What is part of the loop is what's inside this section. Even if you put it there on the top, it's not part of. This is now before the loop, right? Remember, we can't break up blocks from the top, so I need to take that out. And I now need to grab the top. If I grab only the bottom, it will only take out the wait block. So grab the top and slot it into the repeat loop. So when you're running this recording later, you will probably have to practice a little bit. Maybe sometimes you don't get the mouse pointer. With a little bit of practice, you'll get the knack of getting the block to go in the right spot. It might just not happen or go at the bottom or whatever it is. And now our repeat loop can join our first 2 instructions, which was what costume to be putting on and where to start. And look at that. And let's press play. And hello. Now, do you notice that he did exactly the same thing that he did yesterday? Oh, well, earlier when we ran the program. And look at the code. The other program couldn't even fit on the screen. We had to scroll down to see more. Okay, so can you see how it's improved our readability? It has made the program much shorter. And let's look at debugging and how that's going to save us time. Let's suppose we want him to walk a little faster, 0.5 seconds. Oh, here he is. He's on the move. Look at that, right? And I only changed it once. Yesterday, when I changed the 1 second, I had to change it in all the blocks that had 1 second. But because the block is repeated, it's much easier. How about 0.3? Let's have a little fun. Ooh, he's moving fast now. And let's try 0.1. 1/10 of a second, everybody. Here he goes. Ooh, he's gotten really fast there. That's a little too fast. I think 0.2 seconds per step might be just a nice speed for the guy. Here we go. And hello. Okay, so and here we go. We've got this program now in which he is walking and he is walking in a loop. Okay, all good. Any questions? And again, I'll give you a chance to ask me anything before we go to the next what we're going to do next. We're still good with time. Okay. I see some people have fiddled and figured out how to change sprites and backgrounds and so on. Okay, well done. That's good. You experiment on your own. I'm not going to switch my sprite. I'm not going to switch my sprite because I have a specific need for this guy a little bit later. Okay, Ronel, I don't know what you did, but normally if you say practice, save, and then go and check, it should be there. Okay, everybody, now I want, okay, let's save this program. Let's go File, let's save. Right, now I forgot to change the name. It's called Robot Walk 1, so that's okay, right? So we've got our repeat program. Now let's go to a new program. Let's clear up everything. We did save it, so it's fine. Right, I did save the program, and I called it Robot Walk 1. And Robot Walk is the first ordinary one without the loop, and Robot Walk 1 has the loop. Now, what we're going to do is I want you to create a loop for me, and we're going to do it together on the screen. And we're going to use this sprite here. And I'm going to start first so I can save time. And I'm going to do that. And in terms of looks, I am going to preset the size of the sprite. Right, now, remember I told you at the bottom here, you can change the sprite size, right? But every time you run the program, you'll have to go there and do that. Now I'm going to show you how you can set the size of the sprite in your program so that for that particular program, the sprite will always remain that size. If you change it down at the bottom here, you'll have to keep changing it every time you want to run the program. So let's make him, 60% of his size, much smaller than he is now. Okay, and if you want to run the program, you'll see that's 60% of his size. And now here's what I want you to do. First, I'm going to show you what a turn does. Okay, somebody asked about turning the sprite. So let's get him to start there. And let's turn him 15 degrees. Let's run the program. There we go. Run it again. Oh, there's he just keeps turning 15 degrees, right? He just keeps turning 15 degrees. And eventually, of course, he gets back to the same spot when he does a revolution. Let's go 60. Right. Okay, now 60. Okay, now 60 degrees is a bigger angle, so it was a lot less turns for him to make a complete revolution. All right, so let's add a control, wait 1 second, so turn and then wait a second. And here's what I want you to do. I want you to tell me now, how are we going to put these two blocks, the turn and a wait, into a loop so that so that it shows him turning a complete revolution and starting back to where he started. Okay. Okay, so that's what you're going to do, right? Yasin says repeat. Okay, let's be a bit more clear. Which repeat? I got this one, and I got this other one here, repeat until. Which one? Let me put both on the screen. And okay, right, which one shall we use? All right, everybody answer on the chat. Help me. I don't know which one to use. The second one, so I assume you mean this one, right? Great, okay. Let's take that one out, and well done. Thank you very much. For both of you are correct. Right, so we got the repeat one. Okay, so we will take this 2 blocks of code and put it into the repeat loop. Okay, And Zuki is saying that it's a conditional loop. No, this loop we are using is not a conditional loop. It is a counting loop. It's going to count 10 times. Now, here's my next question. We have to change that 10. Remember, our plan is to get the sprite to keep turning until it goes back to its starting position. The question now is, and this is where logic and good, clever thinking comes into play, right? We have to figure out how this has got to work. See, programmers, it's not all about just picking blocks and making things move. When we want to solve a problem, we really got to apply a thing called logic, which is the ability to reason and figure things out. Sometimes math is involved, like in this one. The question we got to ask ourselves is, how many turns does it take him? If he's moving 60 degrees at a time, how many turns does it take him to get back to the starting point? 3 times? All right, Sean says 3. And let's do 3, and let's run the program. And he's, oops, sorry, Sean, he's stuck on the top there. Right, I gotta get him back. Here he is. He's back home. So 3 wasn't quite right. Aiden says 6, right? Oh, okay, everybody's saying 6. Okay, 6 because, now let's work this out. How many degrees are there in a revolution? 360 degrees. That is right, 360 degrees. If he's moving 60 degrees at a time, he needs to move 60. How many 60s are there in 360? Or 360 divided by 60 will give you 6. And so if we put 6 in there and run the code now, here he goes. And voila, he starts all the way back at the beginning. Okay, so that's how you structure the loop, right? So that was an experiment loop, and we were looking at turning. And I'm not going to save this program. It's pretty small, and I don't worry so much about it. Okay, everybody. Now, with the last bit of time left, I just want to do a little bit of animation so that I can give you something to be fiddling with, because you can spend days and days on animation. Okay, we're not going to. This sessions over the next few weeks is really about coding. It's not, animation is fun, but it's a very small part of what we do, right? So, but I know you like this kind of stuff, and I know you find it exciting. So I am going to whet your appetites a little bit and introduce you to a little bit, but I'm not going to focus on animation throughout all that we do, right? Sometimes we'll have to do this real clever logic programming stuff. So when we get to those points, bear with us, because we're really trying to give you an idea of what programming is about, and whether, choosing this course when you go to high school might be, something that you want to do. Okay, so let's have a look at animation. I am going to just chuck the rest of that out. Okay, now, our guys, 60. Oh no, I shouldn't have chucked out the size thing. Let's leave him 60% of his size. That's a good size. Okay, 60. All right, now let's have a look at the sprite. And he's moving across the screen, and we got him moving across the screen, but he doesn't, he just kind of like jumps across. So if you want to animate him, that means make parts of him move. There are a number of ways to do it, but the most efficient way to do it in MS Blocks is actually by creating another costume. So let's actually first let's load the program, the old one. Let me load the old one where we had him walking. That was this one. Yeah, let's load this one, right? Okay, so we got this program, right? That's fine. Let's use this one. Okay, now here he is. And what we are going to do is we're going to go to the costume. So you're going to click on costumes. Okay, that's his second costume. Can you see his first costume? Okay, everybody watching, right? If you look at this guy, we want to give him another costume that puts him in a different position. I remember I said to you yesterday, when we create animations, we draw multiple pictures and we run the pictures one after the other super fast, so the eye is fooled into thinking that it's moving. That is the basic concept of animation. Okay, so if we want to animate the sprite, we've got to fool the user. It's artificial intelligence. It's not really moving. We are just beating the ability of the eye to observe very fast motion. And that's how cartoons are done. So watch what we do, right? Step one, we right click on the original costume and we click duplicate, right? And we make a copy of this costume, right? Notice this one way he's waving is called costume 2. The original one where he's facing forward is costume 1. And this one that we now created is costume 3, but costume 3 and costume 1 are exactly the same. Also notice he's in the paint window, he's just a little bit at the bottom. Can you see these bars at the top there? You've got to scroll down there so that you've got the whole sprite in view, and you can scroll this way to get him all the way in the middle of your screen, right? So this is sprite number 1, sprite number 3, and you can see both of them are exactly the same. Okay, now if we want to make him walk, we have got, or look like he's walking, we have to change. There's 1. We'll take costume 3 and we'll fiddle around with this costume in a specific way. Now, can you see? Firstly, be very careful. This can become quite annoying because all in this costume area, the sprite is made up of different pieces. This is called an array image, right? Watch, can you see I can move that back there? I moved the dot up there now. So I've actually changed how the sprite looks, right? Anytime you do something and you're not happy, you can use these redo and these undo buttons to get it back the way it was. So each of the parts, watch as I click on all these things. Even this image here, can you see this little round thing? It's made up of 5 parts. 1, and then there's this part here, then that one there, then that one there, and then the dot in the middle is another one. So that's basically how the sprite works. So if you look at this, see this arm here? I can take this arm, and if you look, when you click on it, it gives you something called thumbnails, which surrounds the entire object. But if you look at the bottom here, you will see an arrow which allows you to move it or turn it. Just make sure you got the correct one highlighted before you turn anything. Now watch what I do. I turn the hand around this way, and then it's a little bit out of place. I want to get it onto his butt thing there, and now his arm is that direction. Now he's like hand section. I've got to turn that around as well, which was the way that his hand was looking, the other way, right? Okay, so let's turn this thing around a little bit as well. I got too far, and do that. See, as you can see, you got to be very careful. And I said animation is a painstaking process. And now we have moved his hand forward. Okay, now if you want to make him look like he's walking, we've got to this foot has to kind of go in the back, right? So let's take the whole thing out together like that. That's his foot there, right? And let's take this one and move it forward like so, right? And then we'll take this part of his leg and we'll move it so that it fits into his pants. We've got to check, is that right? That's more or less correct. And we're going to do the same with this one. Okay, that's his leg there, his foot. All right, I think his foot was kind of like that. Oh, shoes. Right, that's kind of okay. And if we put that there, and then we put this leg section, let's see if we can grab both of those together. Okay, it's a bit wobbly, not perfect. And of course, you're going to work hard on it to get it right. And so you've got these 2 costumes now. So this is costume 1. which one did I fiddle with? All right, that's costume 1, and that is costume 3. Okay, so we've got 1 and 3. Remember the numbers. Now let's go back to our code, which makes him move. Right now, we switched him to costume 1. We put him in that space. We made him move 10 steps. And okay, let's actually know. In fact, why are we going backwards? Let's go to the one where we made him with the loop in it. I think that's this one. Right, here's the one where he was looped. Okay, so what we will do is inside this loop, we will keep switching costumes. We'll switch from costume 1 to costume. Oh, okay, guys, I didn't save that, so we lost our animation. But luckily, I had saved this on my computer. So let me just load my one, and I can show you what we did there. Okay. Yeah, this is the one. Right. Also, I did change the background. The stage has a bit of a backdrop, so you can find that if you click here on backdrops, you can put the sprite on any kind of background that you want. That's just a plain blue sky, and I use this backdrop here, blue sky. Simple things that you can just fiddle with. So now we can make him look like he's walking in the meadow. Right. Okay. So let's look at what we're doing in our repeat. Right. Let me just take that out, and let's make him. Let's just get it back to what we were doing. If I go to right, remember we said repeat so many times. Right. So there's our repeat loop. And is moving 10 steps, then we're switching the costume, wait 1 second, move 10 steps, and then switch to the other costume, right? So what actually happens is he moves, switches costumes, switches costumes, and if you play that in a sequence, you will see that now it looks like he's walking. And we gave him 10 steps. Notice also that I added a go to minus 300 and 117 so that he starts from the same place every time. Otherwise, he'll just eventually walk off the screen if we keep running the program. I also set point in direction 90 so that if he moves out of space or whatever it is, I want him to always face forward. So his moving is forward. So can you see he moves, switches to costume 3, which is where we switched his hands that way, and we switched his leg the other way, and then he switches between these two costumes at 1 second intervals, well, 0.1 seconds, and it looks like he's walking. Let's change that to 0.2, and this one to 0.2. We won't make him walk so fast. And let's test that. Okay, that's nice. That 0.2 is nice. He's always taking 10 steps, right? If you want him to take more steps, you can increase the number of steps that you've got there. And there he is. And of course, you can increase the animation. I just did that quickly because I didn't want to take too much of time. But you can also fiddle with these other birds and create animations where they move in a certain way. For example, each move can have this little ball going across his head and going back as he moves. You can experiment about with the animation. But really, the bottom line of what I'm teaching you is that let's go back to our costumes, is that it's done, he's not actually walking at all. We are simply, watch this, we are simply switching from this costume to this costume, right? This is the costume. So costume 1, costume 2, costume 1, costume 2. If you switch between those costumes very fast, it would look like he's walking in this case, or it would look like we've animated in. And that's generally how we achieve animation. So the hard work, of course, is sitting here in the costume section and really designing the costumes to make it. That'll take you long. After that, it's just a matter of running one costume after the other to make the animation work in the code. Let's go quickly back to the code. And you'll see that there's a lot more things I had in this code, but we are coming close to the end of the session for today. So we'll go a little bit more into that tomorrow. So yeah, I think we have achieved some interesting things with regards to animation. Yeah, let me save this program as well, because we just kind of, oh no, that was mine, right? This is already saved on my computer. Okay, yeah, so this is it. And then you can go to File and make sure you give the name there and save the program. And of course, you can open them and you can run them. In closing today, I just wanted to introduce you to well, an end product of what animation can achieve. And I got 4 minutes, so I'm going to do this very, very quickly. And then we will close for today. Okay, right, now you will see that this is a complex animation. You can see there's lots of blocks of code, and there's different blocks of code for different sprites. So it's very, very advanced program. Well, not very advanced, but it's gone quite far. There are lots of sprites in this program, and what the program does is it just basically simulates what's happening in an underwater fish tank. Now, firstly, you'll see there is this little jellyfish that is running across the screen. The user, the programmer, can actually, you can see these little things on the side. You can click on it and you can put some plants into your aquarium. You'll see here, there are some fish. When you put your pointer there and click on it, it creates a fish. If your speaker is working, you'll see that we've activated some sound. So you've got a fish moving across the screen. And if you click on fish, you can get another fish there, and you can click on fish, and now I've got 3 fish, and I can click on fish, and it just keeps putting the fish on the screen. You can even put some rocks there. I think you've got different types of plants that you can use in your aquarium. And you can basically kind of create this whole thing, and it's all done. As you can see, I've got 4 fish moving, and the person running the program, he decides how many fish there should be and whatever. So it's just 3 simple things: plants, the fish, the rock. The jellyfish is preset, but this is animation. And you'll see again, those fish, if you go into the costumes, you'll find that they are simply changing the costumes in order to create the animation of the fish. It's bouncing also, not going off the screen. And I want to, in fact, in our next lesson tomorrow, we are going to make our sprite move across the screen, but not go completely off. We're going to show you how we can make him turn when we get to the end. But I want to show you, just so you can see that with this coding, you can do some interesting things. It's a interesting little animation program in which you can, this can actually now be sort of like somebody's fish tank screensaver that you have written in this same programming language that we are teaching you to work with. So yeah, that's something that you can look forward to as we move forward. I've got 1 minute left, so I'm going to sign off for now. Anything that you want to know, I can probably answer one small question before we close the session for today. So I know you're going to start spending some time creating animation. Who knows, maybe one day in the near future, you will be one of these animators that will be bringing us these wonderful animations that we see on Pixar television, all because we introduce you to this. And you can come back and say, thank you, Mr. Gabriel, you taught me this stuff. But anyway, guys, I've got to go. We are out of time. Thank you very much for spending this hour learning about loops and animation. Remember, you've got the slides and the video that you can download if you've forgotten things. I know some people said that they only joined up today for the first time, so you might want to go back and check. All the lessons are on YouTube, so download the previous lessons if you missed out. So guys, thank you very much from Teen Africa Geeks and the Department of Basic Education. Thanks for being with us today. I will catch you again tomorrow at 1 o'clock for more exciting block-based programming. See you guys tomorrow.